All right, let's take a look at Part B. Part B says, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the line y equals -2. All right, so first thing I'm going to lean on the picture here, and we've got y equals -2. I'm going to check real quick and make sure that whether or not that hits that region at all. So if I plug in a 1 for x, all right, which would be the right edge of this, I would be right at -2. So I'm going to go ahead and drop the axis of rotation right through there, right where it would be. All right, so we're looking at a volume. This object is going to have a gap in the middle. So we know we're looking at an integral from 0 to 1 of outer circle minus inner circle, and then we'll have dx. So we're going to have area of the outer circle minus area of the inner circle. That'll give it the band. And then we're going to have the dx at the end for the teeny thickness of each of those cross sections. So I'm going to drop my cursor or my pen on the axis of rotation. I'm going to draw out to the far side. All right, and that's the length of my outer radius, and that's uniformly defined from right to left. So that's going to be the area under the x-axis to the line, which is 1. Or sorry, that's going to be 2 for that section. Plus, we're going to have the top function, which is the x e to the x squared. So we're going to have 2 plus x e to the x squared in there. All right, then we go to the inner radius. Inner radius, we go from this line up to here. All right, and that's our -2x. So we know the distance from here to here is -2x. All right, and the total distance there is 2. All right, so I'm going to think of everything as a positive here, and I'm going to take just 2 minus 2x. That would take care of it. You could also, if you wanted to, you could do -2 minus a -2x. That would be fine as well. All right, but again, I'm going to think of the distances. So I'm going to think of it's 2 all the way down to the line, and I want to get rid of the upper part of that, which is defined by 2x. All right. And if I subtract off that 2x or add that -2x, however you want to think of it, that's going to give me the distance that's below the function, but above the axis of rotation. All right, that little distance there. So the full here is 2, and then down to the curve is going to be, if we think magnitude, 2x. So 2 minus 2x would give me that leftover gap. All right, so this would be the integral that would actually give us the volume of that line. All right, so we're going to just say volume equals, and that's everything we need for that one. There's really nothing else that we need to write up. I hope that helps. Thanks.